IoT. And I think we need this for a common reason. I've seen way too many headlines that look like this. The Internet of Things you don't really need. There's a bunch of other articles that I found all saying that IoT is disappointing, it's not working, and I think sometimes it does happen. But what's really interesting, at least in my experience, is when IoT fails, it fails in systematic, repeatable, consistent ways, which is great, because we can identify those and make sure we avoid them. And that's what this talk is all about. So the audience that I built this around is the consumer audience. I realize there are people here that work at companies that make Internet of Things devices. There are people here that are just trying to learn what IoT is for the first time. At the end of the day, we're all consumers, so everything in this talk is built around the consumer experience. That said, the B2C consumer use case definitely translates over to the B2B, business to business, industrial. All of these lessons learned apply more broadly. And in particular, this talk is for the teams that build IoT devices. So if you're on a team and you're a designer, or an engineer, or a business person, and you're thinking, I gotta get me some of that IoT, or someone's coming to you and pitching their great IoT solution, and you don't have any tools to figure out, is this worthwhile or not, that's what I'm gonna try to answer. And I divided it up into 4 questions. So, what is IoT? It's amazing that we're at a conference like this and there's still not a consistent definition. I'll give you my own. What is not IoT? I think it's really important to recognize the differences between IoT and conventional devices and smartphones. IoT is its own thing. Why does IoT disappoint, and then why does it delight? So let's jump in. In the simplest sense, what is the Internet of Things? I would say the Internet of Things is a solution to a user's problem. A user's trying to open up the door, and we have this great solution, a key, and that solution is going to solve the problem for the user. It all begins with the user and their problem. It should go without saying, but more valuable problems have more valuable solutions. Coming back to that first headline, the Internet of Things that you don't really need, I think a lot of the times when I've read those articles and you get into the details, you realize that the IoT device itself isn't really solving a compelling problem. And if it's not a valuable problem, I can guarantee you that it's not going to have a valuable solution. So everything starts here. Another thing to remember is when you're looking at the problem, problems don't live in a bubble, solutions don't live in a bubble. You might have this great new fancy key or IoT key, but there's probably an already existing solution. And the question isn't, does your IoT device solve that problem? It's, how does it compare to the status quo? How does your fancy schmancy key compare to the existing key? And one of the really interesting kind of tricky things with IoT, I'm going to leave the key and door metaphor, go to icebergs. We talk about IoT devices, but IoT devices have this situation where the device part, the thing that we hold in our hands, that's really clear. But there's a lot of underlying complexity. Where does the device begin and the internet end and all that? There's a lot of complexity around IoT, and I think, again, that's part of why we have this challenge. Some people I've heard say, IoT is groundbreaking, there's never been anything like this. I disagree, respectfully. I think this is a story we've heard before, and in many ways, IoT is a story of the evolution of the internet itself. So what does that mean? That means in the 1990s, in the simplest sense, the internet meant that people had access to all the data in the world. The catch was we largely used desktop computers, which meant that we had to physically be tethered to a certain location, our home, our office, wherever those computers happened to be. But we had access to all that information. 2000s come along, this is wonderful, now that we have the phone in our pocket. That means that we have the internet in our pocket, so we have access to all the data in the world in all locations. We're no longer tethered to that desktop. And the 2 main use cases that we had were dealing with other people, like writing on Facebook or a blog or newspaper. We're dealing with machines, like looking up a recipe to cook pasta and setting the temperature on the stove for lasagna to 350 degrees Fahrenheit. And so the idea, to me, in the easiest way, is when we're talking about IoT, we're saying we're no longer going to have a human as the intermediary between all the data out there in the world and the devices that we want to use the data with. So I'm going to have lots of fun examples throughout. This is the Ring Video Doorbell. It's a great example of an IoT device taking the people out of the equation. Person walks up to the door, this handy-dandy device captures a short video of that person, sends it to everyone who has the app on their phone, greatly simplifying giving access to locations and identifying who's there. We have one of these in our office at Orange. I'll be sure to tell you a bit more later in the presentation about what we're doing at Orange. Just as a quick side note, if you're not familiar with Orange, it's a large French telecommunications company similar to Verizon or AT&T here in the States. So let me give you an end-to-end example. I'm all about end-to-end examples. So before the 1990s, if you wanted to get somewhere, you had to go get a map and answer the question for yourself. In the 1990s, Waze was great. It solved that problem for us, with the caveat that we couldn't take the information with us. We had to print it out. So this is the Waze printout. You guys might remember this. So the MapQuest printout. Waze did an even better job than that. They said you can have the information in your pocket, take it with you, but the human was still the intermediary between the information on their screen and their car. They had to be that intermediary with the device, and so the self-driving car project, great. No more humans needed, send the information directly to the device. I promised you a definition of IoT. This is my definition of IoT. I would love what you guys think about it, but I would say IoT in the simplest sense is sensors, connectivity, computation, and user interface. What that looks like is you have sensors, they're gathering lots of data about the world around us. Connectivity, we're getting that data out of the device itself, putting it out into the cloud. Computation, when it's up there with this huge data set, we're able to extract insight from it, do something useful with that data. And user interface, expose those insights to the user. If I had to boil down IoT, it's those 4 parts. Optional components, batteries. Batteries are great. That means that we can take our devices anywhere we want. They're no longer tethered to the wall. And actuators, if you don't know what an actuator is, you've used them, you just don't realize. Actuators are basically the opposite of sensors. So if a sensor takes what's happening in the real world, like sound and light, and it converts it to digital data, like a camera or a microphone. Actuators do the opposite. They take digital data and they convert it to something happening in the real world. So the display on your phone emits light, the speakers emit sound. Sensors and actuators, these are things that are often found in IoT devices. So that's my quick argument of what is IoT. So now let's talk about what is not IoT.